everyone, there is a small introduction from my side. I'm working as a software developer in Accenture. I'm mostly working with cloud-native applications and microservices. Today we will talk about the object relational mappings. When I started back in 2020, interested into development during the pandemic, I understood that the modern technology like object relational mappings I could use, and which will make my development process much more easier, like Prisma, Sequelize, and I could stop worried about the SQL injections in general. But when I saw the real cases from the world, which vulnerabilities it had in general, I realized that ORM is not secure as expected. Today, and I took for myself some lessons. The modern technology means that there is modern vulnerabilities. We always need to validate all our inputs and before it will reach the database layer. And we are always trading off our security to our convenience features. Let's talk about a bit of history. I know we already discussed in the previous speeches about the history of MySQL, so I will keep it short. SQL was around 50 years and MySQL about 30. Well, today we are celebrating it. But there is one small story about it. When MySQL was created in the basement by the Swedish developer Michael, and he named it based on his daughter, Mai. And the basement story became today one of the powerful tools which is used by giants like Facebook, YouTube. And when we are talking about the giants, the first thing that comes to my mind is billions of users. And in that case, the most critical part becomes the security. Now, let's discuss about the object relational mappings. What's it's in general? If I would explain it to 5 years old, I would probably say that it's a translator which understands you in your own language, translates it to the database level language, and returns back to you the results. There are a lot of benefits of ORMs, like simplified database, SQL injection prevention, reduced boilerplate code. Who doesn't like the CRUD operations which we could use and we shouldn't repeat them? Also database agnosticism. But as everything else, it has own hidden risks and own vulnerabilities. Let's take a look on the illusion of safety. It's not a firewall. It has the own. It can have the false sense of security. It can contain own framework vulnerabilities and bugs. Now let's switch to the real case scenarios. At Shopify scale. At one of the Shopify scales, the attackers used one of the ways to they increase the quantity of cart to the absurd number, and at the end of the day, the ORM created billions of Ruby objects, and as a result, it triggered huge garbage collections. The impact of it was big. As a result, the service was denied, CPU was in the high usage. Therefore, there is some takeaways which we should take care of. One, we should always validate our input, also in our business layers, and as a result, when it will reach our ORM or database level, so it already will be validated. We should also apply the database level checks, like check constraint to enforce the realistic limits on our users' input. Let's talk about another disaster which happened in 2012 when a researcher rails mass assignment flow against the GitHub. They managed to push their SSH key to another account as a part of the JSON payload. As a result, it became available, and it was not the SQL injection issue, it was ORM issue. And as a result, it was massive. As a result, it was publicly available. The main parts which we should take for ourselves, we should use the strong parameter whitelisting, block sensitive fields from the client JSON, and add the test to the model binding. So another story. Moved in 2023, the poster child for why SQL injection is still pays. Attackers exploited zero-day SQL chained it to exploit web shells and automated data exfiltration. They monetized the whole through the extortion. The campaign hit of thousands of companies, universities, as a result exposed the millions of data. This is the result. As a result, we should always patch immediately, harden web input handling, and we always should monitor everything for the anomalous queries. One of the tools which we are using for the data visualization, let's take as an example like Superset. It dynamically built SQL. Vulnerabilities discovered in 23rd, 24th year showed that ad hoc queries and unsafe SQL fragments could bypass intended control. Because Superset is used in many large organizations, common vulnerabilities enumerations were taken seriously. Now, today, if we are using the BI tools and we are trying to get some data, we need to treat the data as a hostile. So we need to restrict the access to provide only data which we are intended to provide, and always restrict with the remote role-based control access. And let's talk about the evolving risk factors. Just because your app is not a headlines, it doesn't mean that everything is safe. Still, we need to take a look. Usually, when there is attackers and there is a leakage of some data or information, they are not leaving any trace, and therefore we need to be more careful. Now, nowadays, we have low-code, new AI-generated codes, and they are just increasing the level of the possibility for the security vulnerability. So we need also review them manually for not ending up as one of those disaster incidents. Before we will dive into technical side, how these attacks actually happened, let's start with small activity. Which of these code snippets is vulnerable to SQL injection? I will give a moment to take a look. Now please raise your hands who thinks the answer is A. Looks no one. Okay. Who thinks the answer is B? Much more people. And who thinks the answer is C? Okay, 2 people. The correct answer was B, as most of people provided. So in the first case, we are using replacement. Therefore, it is a secure way of demonstrating this query. On the B answer, it's vulnerable to the SQL injection because of the string. We are not parameterizing or doing anything for the data type and passing in the input to the query as it is, which can make vulnerabilities. And for the C option, we are parameterize the input itself. Now let's do one more. Which code snippet might be vulnerable due to ORM framework quirks?
Oh.
Who thinks the answer is A? 3 people. Who thinks the answer is B? Who thinks the answer is C? Yes, correct. As we know, the version before, Sequelize version before 4.44.3 had framework vulnerability.
And A and B are fine?
It's more secure, yes.
Even string interpolation.
Because in the third option, it's a version before, and those are using the kind of current version. So it was fixed later point. Now let's talk about the operations, how in generally it works. ORM operations like from the left side it looks safe. We are just passing in the query and trying to get the information. But let's say the user will direct instead of the query or the string itself just some part of the query, because as a result the user is the one who is shaping the query itself from the input side. And that's why it's not safe to use these operations as it is. We can switch, transfer it to the string or set the data type itself. Let's take a look another type. Leaky relationship. Yes, ORM makes it easy to model the relationship between the objects like user, hosts, password, titles. It fetches the data automatically. But sometimes it also includes the fields which we don't want to expose to external endpoint. By default, it means that if we will use a default behavior, we can unintentionally leak some sensitive information. So we should not rely on the ORM's default behavior. Always whitelist what field should be returned and assume that anything left can be exposed to the external endpoints. SQL injections. On the left side, again, this looks very safe. Developers often assume that ORM makes queries safe because it hides the SQL injection behind. But danger is some users can abuse the input itself, so usually that's the attackers. They can go just much further and add another shape the query in the way, not just take a couple of rows, but use some automation or shell scripts to take over the control. Now I would like to do some demo. Now I have here on the left side the vulnerable version and here the secure login. So this is the email and password which I already have in the database. So we are retrieving the success case. Now if we will want to, let's say we don't know the password and I am the attacker, and let's, for the trying with the wrong password, just to show that it will throw an error. Now if I will pass in the query itself, it still will go as a success. And here is secure version. I will show on the implementation at later point. And now let's try one more. So if we want to get it published, let's say it will take a Boolean response. Yeah, I know in the real website we would probably use the drop down. Just this is for the showcase. And let me add the part of the query. And this is the result. It still will return. So basically my input shapes the query itself and returns the response. Now let's switch back to the presentation. So basically the insecure login was implemented by this code. When we are not setting any type or don't filter it out, so this injection happens in the query itself, and instead of the passing a real password, it will just shape the query as a part. Now this is the safe approaches which can be used. As in first example, we can set to string and convert the data type. And another secure approach would be validating by this schema, if we already have it. So we have usually when after the real world cases and exploring how the attackers can even impact our system in general, this is kind of checklist which I would use for myself. I would be ensure that my inputs are validated before it will reach the ORM layer, that I have used parameterized queries for all dynamic inputs. I have enforced database level constraints as a backup. I should always monitor for the logs, query anomalies, and never trust the client-side filters. You should validate everything on the server side to be sure that everything will run smoothly. ORM is a powerful tool that simplifies the database interaction, which we can use, and it has a lot of great features which makes the development much more easier. But at the same time, security is the shared responsibility. So when developers, DBAs, security teams, they're all playing the crucial role for the ensuring that we will have the right security strategy and protect our sensitive data. So I just want to make awareness that the goal is not turn everybody to security experts, but at the same, but give awareness that you should know where to look, and if something goes wrong, you will find it easily, so you could find the solution right away. And thank you very much. This is a QR code for LinkedIn. Do you have any questions? Thank you.
Questions?
No.
No.
No questions. So you forbidden questions or
No.
Everybody is so scared.
everybody's so scared? Everything was so clear or nobody understood anything? Okay, and now those guys who answered wrong to those questions you asked, they are now just ashamed to ask questions. That's the thing. So you had the ABC option. Those who answered wrong, they have questions, but they
Maybe
are afraid.
just one question.
Okay, one day.
From your experience, I believe you have rich experience in that. How to motivate to make people think about security when they develop the applications? Because from my experience, security goes the last thing they think about. If there was no requirement from the client who ordered the product, how to make them think about security by default?
I would say maybe add test so it will be opened anyway as a bug. From the other side, if the security breach will happen, the impact of it will be much more bigger. So it kind of should be a motivation for not losing the project, at least for the consulting.
But they can say there was no requirement to make this secure and not this secure.
That's unspoken requirement.
Because thinking about security is quite a complex problem. Not problem, but task. It takes much of time, takes much of power to think what will happen if we will do in such way and in such way, to communicate with DBA, with system administrators and with everyone. It takes just time at least. And that's why most of them, no requirement, no implementation.
Something is written in law, as I understand. So you have to observe what is written in law.
But usually there's a different security teams in most of the projects, and it's not just requirement; it's just one part of the software development. So it needs to be much more secure than just for the demo.
Or in your work time, what you do, you're just constantly breaking your colleagues' code and help them see the necessity of security.
You could be fired for that.
Okay.
No, maybe create a small games. If you find your colleague's bug, you will be rewarded.
Oh,
But will it motivate them to create bugs even more, to then find and reward themselves?
you yeah, you ruined everything.
It's like the snake problem.
Yeah. Any other questions? No more brave people? So, Aytaj had this serious task to find the person whom to give a cup from Accenture and Latvian Oracle user group. So it comes that you will have to take it.